Hi everybody. We're going to look at the second practice test for the second exam for the College Trig class through WVU. Through this, the test that I had looked at had only 17 questions instead of the normal 20, and they're all a mixed bag. So let's get started here. Question number 2. Convert 7 pi over 6 to degrees. Use a whole number for your response, and they don't want any decimals. So we have 7 pi over 6. And remember that we are using 180 over pi. So whenever you use your 180 in pi, just make sure you set it up so that the pi's always are diagonal, so they'll cancel out. That's how I remember it. Pi's go diagonally. Okay, so your pi's will cancel out. You'll do 7 times 180, and that gives you 1,260 over 6. And then you can use your little scientific calculator and divide that out. And that gives you 210. And don't put the degrees in the computer, just put only the number. Okay, question number 3. Match the trig function to its value. So sine of pi over 3. So there's 2 different ways you could do this. If you are allowed to have a scientific calculator, you could just type that in. Sine pi divide 3. And then you would hit the button, and I believe because this is pi, I probably need to change this from degrees to radians, because I don't believe that is one of our answer choices. So anytime you get something weird, just change this. So I'm hitting degree, I'm going to move it over, change it to radians. All right, try it again. 0.866. So now I need to figure out what is the square root of 3 over 2. .2. Oh, it's square root 3, then divide 2. Oh, I totally typed that in wrong. Okay, I couldn't read the, right there, that line's printed over it, and I couldn't really read it. So it's square root 3, then divide by 2. Okay, 0.866. And this would be the negative one. And then this would be the positive one. So if you get a calculator that can do trig functions, that would be your quickest way of getting your answers. If you don't have that opportunity, then you're going to have to work these out by hand. So pi over 3, that would be, let's draw our little trig circle here. So let's put our 60 degrees down here. We've got our 90 here. That means this top corner is going to be 30 degrees. Now, when you draw your trig triangle, remember the 3's can never be diagonal from each other. So that means diagonal from the 30 has to be the 1. The hypotenuse, which is diagonal from the 90, is always 2. So that means diagonal from the 60 is the square root of 3. Okay. So pi over 3, that would be, and that's sine, so sine is opposite, so square root 3 over 2, so this answer is F. Okay, we'll go with this one. Cos of pi, so I would draw that out over here. So pi would be over here, so this is one of those fake triangles. So this is technically pi. So we're going to draw a triangle up here. Okay. So the hypotenuse on the fake triangles, this is 1. The hypotenuse would always be 1. The side where your Your at would always be a 1, so that would be 1 right there. And then this side here would be a 0. And of course, this would technically be a -1 since this is on the negative side over here. So the cos of pi would be adjacent over hypotenuse, so that would be -1. So -1 over 1 would be -1, so that is C. Of course, you can type these in your calculator and get way faster than that. Okay, sine of 360 degrees. So we'll draw another one here. So 360 would be over here. We'll draw our fake triangle. So here's the 1. This side doesn't exist, so it's the 0, and your hypotenuse is always 1. So sine would be opposite, so 0 over 1. So 0 over 1 would be 0. So that would be A. Okay, cos of 300 degrees. Okay, 300 degrees is not, is that one of our normal triangles? It is. Okay, so this would be 360 degrees. This would be 270. So 300 degrees has to be in the middle right here. So this would be your 300 degrees, okay? So 360 minus 300 tells me that my reference angle is 60 degrees, okay? So since that's 60, we know the hypotenuse is always 2. Diagonal from the 60 has to be a square root of 3. And the 1 is always diagonal from the 30, okay? Now, since this is going down, this square root 3 would be a negative square root 3. So it does kind of follow the quadrant laws on that. So cos would be A, which would be 1 over 2. So this would be 1/2, so that is E. Okay. All right, sine of 5 pi over 3. So I feel like I'm unfortunately running out of space here, but I guess I'll draw it right here. Okay, so pi over 3 would be 60 degrees. So here would be your pi over 3. Here would be 2 pi over 3. 3, hold on, that doesn't look right. Alright, let's try this again. I knew that this was wrong because I was trying to put that as 3 pi over 3, and that reduces to just pi, and I knew that that had to definitely be wrong. I don't know what I was thinking this morning. So this would be 3 pi over 3. So it's 60 degrees, so this would be pi over 3, and then 2 pi over 3 would be here. Then you would have 4 pi over 3. So 5 pi over 3 would have to be in this quadrant right here. And since it's 60 degrees, it's the same triangle as that one over here. So this one over here, we're looking at sine. So it would be negative square root 3 over 2, which would be D. Okay, and then secant of 60 degrees. Well, here's our 60-degree triangle. Secant is kind of like the opposite of cos, so it has to be h over a. So it would be 2 over 1, which would be 2. Oh, and I forgot to star the ones that I saw on the test. I saw both of these types of questions, 2 and 1, on your test. 2 and 3 on your test. Okay, exam 4. Find the exact value of sine squared x if x is equal to pi over 3. So you're going to take sine, and since this is x, this is going to be pi over 3, and it's going to be the whole thing squared. Okay, so the first thing you need to figure out is what is the sine of pi over 3. So pi over 3 is 60 degrees. So this is square root 3 and 2 because it's diagonal from the 90. So sine would be square root 3 over 2. And of course we have to square that, so we would distribute that 2 to both of these, the top and the bottom. So it's square root 3 squared divided by 2 squared. Well, these cancel out, so that gives me 3 over, and 2 squared is 4. So your answer is 3/4. And I believe you could have just typed this part right here into the calculator and it should have given you 3/4, as long as you were in radians. If you see a pi, your calculator needs to be in radians. Okay, so we have sine, and I probably need a parenthesis to start with also. So parenthesis sine pi divided by 3, and we would square that. And see, that gives you 0.75, which is 3/4. So that's another way that you could do the exact same problem. If you get a scientific calculator, it will be super handy for this exam. Alright, question 5. If sine of x equals 0.4, find the value of cosecant of x. So there is a formula or a rule that says the cosecant of x is equal to 1 over the sine of x. So that would be 1 over 0.4, and 1 over 0.4 is 2.5. I'm forgetting to star these, but every single one on this page, you can go ahead and star. I saw every single one of these similar on your exam. Okay, question 6. This might be one of the easiest ones on here. If the reference angle for an angle, it says find the reference angle for an angle of negative 30 degrees. So anytime the angle is positive, we go this way. If it's negative, you go backwards. So right here would be negative 30 degrees. So this question is asking you, what is the angle measurement between here and here? Well, it's just positive 30 degrees. So that question is the easiest one on there. And luckily, I saw one similar to that on your actual test. Suppose the cos of theta is equal to 3 over 5 and theta is in quadrant 4. Find the exact value of tan of theta. So I always start with drawing these. I know I'm in quadrant 4. So I know I'm down here. So cos of theta, so adjacent would be here. So that would be 3. And your hypotenuse would be 5. So you need to find this one right here. I would do Pythagorean theorem. At this point, you should know if you have a 3 and a 5. A 3, 4, 5 is the most common triangle. But for the video's sake, I will go ahead and show you the Pythagorean theorem. But you should have that memorized. But we have 5 squared is equal to 3 squared plus b squared. So the Pythagorean theorem is just a squared plus b squared equals c squared. I just wrote it down a little backwards. So we have 25 equals 9 plus your b minus your 9 on both sides, and you get 16 is equal to b squared. Square root that, and we get b equals 4. Now because this is going down into the negatives, it's a negative 4. So tan would be opposite over adjacent. You need to have all of those memorized. Here's your theta right here, so the opposite is diagonal. So we get negative 4, and the adjacent would be right beside it, so it would be 3. So our answer is this one right here. Okay, next one. Match the trigonometric function indicated by the domain and the range. Your answers may be used more than once, and more likely they will be. Okay, domain of sine. So if I was looking, and you're going to need to have those memorized since you don't really have a graphing calculator. So sine is the one that starts right here and it goes up to 1 and down to 1. And then of course it continues on because it's just like a bunch of wavelengths. So the domain is going to be from negative infinity to infinity since the wavelengths continue on and on. Our other answer choices are over here on the other page. So that would be B, all real numbers. I'm guessing it's going to ask for the range. So if we're looking at the range, it would go up here from +1 to -1. So that would be from 1 to 1, so that would be A. Okay, cosine. I'm going to draw that right here, I guess. Cosine is the one that starts at 1, and then it goes down and then up, and of course it continues on. So that's the one that's cosine, so it would be all real numbers for your domain. So that would be B. And the range would be from 1 to -1. So that would be A. Alright, tangent's the only one that is a little bit weird. So I will show you what that looks like in the graphing calculator. You do need to have that graph memorized for your exam. Now when you're graphing, you need to make sure you go to mode, and it needs to be in radians. So you will need to change that. Go to your y equals. We'll hit tan x and graph. So the graph looks like this one. You will need to have it memorized. So it just does a bunch of these things. Okay. So the domain on here, well, it skips right here. And the only one that has anything skipping would be C, all real numbers except for odd multiples of pi/2. So that would be C. Now when you look at the range, from here to here, these would continue on. Since the arrows are in opposite directions, that would be all real numbers. Okay, question number 9. For what intervals is the graph cos of x increasing? Okay, I kind of already have the graph drawn right here. So it would end at 2 pi. This would be pi. So we're looking at where it is increasing. So it would be from pi to 2 pi for sure. So we'll mark that. Alright, 0 to pi. So from here to here is going down. So that's not an answer choice. 2 pi to 3 pi. Well, if this keeps continuing on, it's going to go up and down. So it can't be that. Alright, pi/2, which would be here, to 3 pi/2, which would be here. Well, it goes down and up, so it can't be that. Okay, negative pi, which would be right here. So negative pi to 0, that's increasing. We'll check box that one. And negative pi/2 to positive pi/2, well, that would be from here to over here, so it would increase and decrease, so it's not that either. I did see one similar to this. Of course, they might change increasing to decreasing. They could change cos of x to sine of x. and then change the increasing and decreasing. So it won't be these exact same problems. So don't memorize the answers to these problems. You need to know the concepts to the problems because they're going to change these throughout the whole thing. Okay, 10 and 11, you might as well go ahead and star both of those. I saw both of those on the test. Okay, question 10. What fact about trigonometric functions does the figure illustrate below? Okay, so first thing we need to know is always skip trig class. So that's how I remember, and I just start in quadrant 1 and go all the way around. So the phrase is always skip trig class. Alright, so that's going to help us out memorizing that little saying on here. So always means that they're all positive. S is for sine, so sine is the one that's positive. T is for tangent, so the tangent would be positive, and C would be for cos, so the cos would be positive. Okay? Alright, in quadrant 2, the sine is positive and the cosine is negative. Yep. That's definitely true. In quadrant 2, sine is negative. Nope. In quadrant 4, sine is positive. Nope, that would be cos. And remember, this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4 down here. In quadrant 4, sine is negative, and the cosine is positive. What? Sine is negative and cosine is positive. Alright, now this is actually true. Sine is negative in quadrant 4 and cosine is positive. That is a true fact. However, if you look, A is indicated that it has to be in quadrant 2, not quadrant 4. If the little circle had the little A down here, then I would say, oh yeah, that's definitely the one. But since all the rest of these is quadrant 4 and quadrant 3 and quadrant 3, and our A isn't in quadrant 4 or 3, the rest of these are all wrong without even having to read any of them. Alright, question 11. Find the exact value of 4 sine pi over 3 plus 2 cos pi over 4. Alright, so I like to draw the trig circle here. So pi over 3 would be 60 degrees. So I know diagonal from the 60 has to be the square root 3. And then the 2 is diagonal from the 90, so this has to be the 1. So this is my pi over 3 one. And then the pi over 4, you will also need to memorize this one. So here's my 90. Pi over 4 is 45 degrees. So this is the one with all the 2's. So diagonal from the 90 is 2, and these are square root 2's. Now, other trig books will use different numbers around here. I think they use 1s and stuff. I don't do that because if you have it set up like this, you don't have to reduce in the end. So that's why I memorized 2, and then these are square root 2's. And because there's a lot of 2's in it, it just makes it easier that 2 is always the number diagonal from the 90, so the sides have to be the square root 2's. I think it helps to make it memorize it easier. Okay, so we have 4, and then I look at this triangle, sine of pi over 3, so that is opposite over hypotenuse, so we have square root 3 over 2 plus 2, and then pi over 4, and we're looking at cos, so it's square root 2 over 2. See, I didn't have to reduce. Okay, so 4 divided by 2, that would be 2, so this is going to be 2 square root 3. And 2 divided by 2 would cancel out, so plus the square root of 2. And so our answer would be this one down here. I do believe you could also type that into the calculator and get a decimal, and then type in all of your answers and get decimals and compare your decimal answers. That would be another way of doing this also. Okay, question number 12. For each of the terms, select the corresponding quadrant. Okay, so we're going to go back to always skip trig class. So here they're all positive, sine's positive, tan's positive, cosine positive. We got quadrant 1, 2, 3, and 4. Okay, that's going to help tremendously. So sine is greater than 0, and so that means sine is positive, basically. And the cos is greater than 0. So that means both sine and cosine are positive, so that only happens in quadrant 1, so this would be D. Sine is less than 0, so sine is negative, and cosine is positive. So if I look at that, that would have to be quadrant 4. So that's the one where cos is positive. So that is B. Okay, sine is greater than 0, so that is positive. And cosine is negative. So that would be right here, quadrant 2. So that's C. I did see one like this on the test. I'm pretty sure that these are going to change. So make sure you're really watching your A, B's, and C's. Sine is less than 0, so sine is negative, and cos is negative, which means tan would have to be the one positive, so that would be quadrant 3, so that would be A. Okay, now let's see if I can count better this time. So pi over 3, 5 pi over 3, that would be 60 degrees. So this would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so that would be quadrant 4, which would be B. And of course, you could have also done 5 pi over 3 times 180 over pi, and make sure your pi's are diagonal. And you could have worked it out that way so that you can figure out exactly what the degrees was, and maybe you think better in degrees wise. So if we did that, I would get 900 divided by 3, so that would be 300, so that would go over here. So I don't know how you're going to think about that, but, be thinking about that. Okay, 7 pi over 4, so that would be 45 degrees. So we would have a pi over 4 here, a 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So 7 pi over 4 would be in quadrant 4, so that would be B. All right, 11 pi over 3. So we'll just continue with our 5 pi over 3, which was 60 degrees. So the next one would be 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, and then 11 pi over 3. So that would be also in quadrant 4. A lot of B answers in a row. All right, negative 2 pi over 3. So that means you're going to go backwards. So this would be negative pi over 3. So then negative 2 pi over 3 would be over here. So that would be quadrant 3, which is letter choice A. Okay, 7 pi over 6. So that would be the 30 degrees. So we've got pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, then we'd have 7 pi over 6. So that would be in quadrant 3. So that would be A. And 5 pi over 4, I believe I already got that over here, so that would be 3. So that would be A. Okay. 13, and I did not see this one on the exam. That doesn't mean it won't be on there, I just didn't see it. A biologist discovers that the suicidal graph is appropriate to model the population of wolves on an island as a function of time. What does the period of the function represent in the model population? So it has to be time, since it's on the bottom there. So it's the time between the successive peaks of the wolf population. Because if you looked at a graph, you got peak to peak to peak. Okay? So it wouldn't be the time for the population to double, because that would be from here, and then it would be more of like a straight line. That would be linear. And the other ones don't even make sense because it has to be time. Okay, 14. What fact about trigonometry does the figure below illustrate? Okay, so you want to look right here, and this will help guide you where you're going to be at. So you need to try to figure out how many degrees you're at on this triangle right here. Okay, so if I look, I'm looking at 120 versus 150 degrees. Okay, so, here's 90. I mean, just kind of looking at it, it looks like that would be 120, and 150 would probably have to be closer to here. So it does look like this is going to be closer to 120. So 120 degrees. If I would convert this to pi's, I'd have pi over 180. So that would give me 2 pi over 3. If I would look at that, I know I have to be over here. So I would have the square root 3 right here, since this would be a 60-degree reference angle. This would be -1, and then this up here would be 2. All right, so if I'm looking at this, sine of 120 degrees is equal to -1/2. Now, that is a true statement, but look at where my graph is starting. Because my graph is starting at 1, for it to be sine, it would have had to be down here. So I know all the signs are wrong answers. Okay, now looking that this is closer to 120 and 150 would be here, it's got to be one of these two answers. So I just need to figure out which one of these two is the true thing for cos. So I look at cos, that would be -1 over 2. So that would be this one here. Oh, and I was wrong about this one up here. I don't know why I said the sine of 120 was -1/2. That's not even a true statement. That would have been square root 3 over 2. I'm not sure what I was thinking. But you do need to look at where the graph starts up here, because that does rule out sine versus cosine. So if it started down here and then the graph went down here, you would be picking one of the ones that had sine. Okay? And I did not see this one nor 13 on the exam. Okay, question 15. Definitely saw that one. Determine the amplitude of the sinusoidal function y equals sine 4x. Okay, if you see this word right here, that's just a big word for the sine function. Okay, so you're looking at the sine function of this. So amplitude, this should be fairly easy. It's just that right there. And it's literally the definition. So your amplitude would be 2 because it's the number in the front. Okay, question 16. And I'm going to show you 2 different ways of doing this question. I definitely saw something similar to this on the test. Of course, they're going to change the numbers and stuff. A rain gutter is constructed of aluminum sheets 24 inches wide. After marking off the length of 8 inches from each angle, this length is bent up at an angle X. See the figure below. Find the exact cross-sectional area of the gutter when X is 60 degrees. Alright, so we're going to go through the short method, which will require you to memorize a formula, or the longer method, which doesn't require the formula, but has a lot more steps and it's a lot more involved. Okay? And it's just going to be up to you as to if you want to memorize the formula for the test or if you don't. So the formula is A of theta equals L squared sine theta cos of theta plus 1. Okay, this would be the short method, and this would be the formula that you would need to memorize for this problem on the test, if you choose that this is the method that you want to use on the test. Okay, so your L would be 8, and of course that number will definitely change on the test, so that would be your 8. And then your thetas would come from here, and that number would definitely change. So this would be your thetas. So we'll plug this in the formula. So I have 8 squared sine of 60 cos of 60 plus 1. And then you will go through the process of solving this equation. Okay, so 8 squared is 64. I always like to draw my triangles out. So we got 60 degrees. I know diagonal from the 60 has to be the square root 3, 2, and 1. So I know the sine of 60 is square root 3 over 2. Cos of 60 would be 1/2 plus 1. Okay, so right here with the 64 and the 2, I can reduce that. So that would be 32 square root 3. And 1/2 plus 1 would be 3/2. Now I can take the 32 and divide that by 2. So that would give me 16 square root 3 times 3. And then I would take 16 and times it by 3, and that gives me 48 square root 3. So that would be your answer right there. That is the short method, and for the short method, you would have to memorize your formula, and you would know that this number would change, and you change the number in front, and the x changes, and you put the number in for the thetas. Okay? All right, now the longer method, which does not include memorizing a formula. You're basically creating the formula yourself. All right, so if I'm looking at my triangle, I'm going to take basically like this chunk here. I'm going to redraw that here. All right, so I'm looking at theta. I have my W, my H, and this is 8, okay? Because it tells you that your length from here to here is 8 inches from each edge, bending it up. All right, so the sine of theta is H over 8. And we're going to resolve this for the height. Okay. All right, so for h, I would times both sides by 8. So h equals 8 sine of theta. Okay, now I need to solve for w. So w would be cos. So I would have cos of theta is going to equal the w over 8. And of course, I want to solve for w. So I would times both sides by 8. So w would equal 8 cos of theta. Okay. So that's going to give you the triangle. So our formula for this is going to be area is equal to the rectangle. So that would be your rectangle here in the middle, plus I have 2 triangles. So plus 2 triangles. So like I said, you would be generating this each time on the test. All right, so the area of the rectangle right here would be your length times your width. So I know that that would be h times the 8, because they told me that this is 8 and this is 8 and this is 8. So this, all of these bottom pieces here, all of these are 8s. So length times width, so h times 8. So I have 8h for the rectangle. Okay, for the triangle, I have plus 2 times 1/2. And formula for triangle is base times height. So if I'm looking at this triangle, I have my base and my height, but I'm using w and h. So w instead of base times the h. All right. Now I know my w is this and my h is this. All right. So I'm going to start plugging this stuff in. So I have 8 times the height is 8 sine theta, plus these 2 things here are going to cancel. So really don't need to worry about the 2 and the 1/2. So I've got my w, which is 8 cos of theta, and my height is 8 sine of theta. All right. Now you're going to need to, I can times these 8s together and simplify it a little bit, but I'm going to need to plug in the 60 into the thetas. All right, so 8 times 8 is 64 sine theta, plus the 8 times 8 is 64 cos theta sine theta. All right, now we're going to plug in the 60 degrees. So I have sine of 60 plus 64 cos of 60 sine 60. And you can use your triangle that we had drawn way up here to figure out what your sine and your cos is. So sine of 60 degrees was square root 3 over 2. Cos of 60 is 1/2. Sine of 60 again is square root 3 over 2. Okay. All right. Half of 64 would be 32 square root 3. So I just divided that out. Half of 64 again would be 32. And then I would take the 32 and cut it in half again. So that would be plus 16 square root of 3. And 32 plus 16 is 48 square root of 3. So you can see where this method has a lot more work involved. Memorizing the formula was a lot more simplified, I guess. It just depends on, do you want to draw your triangle out and derive it every time, or do you want to memorize the formula? All right, then turn to the back. This one really kind of wasn't drawn on there, but we're going to add it in there. So I think it will help you out. All right, I'm going to actually write this one out because it's really involved. So consider the cosine function f of x and the related function g of x equals 1 plus f of x. And I would probably, pause the video and make sure that you have this all written out, okay? Does g of x have to be periodic? If so, how is the period? Of g of x related to the period of f of x. And how is the amplitude of g of x related to the amplitude of f of x? Okay, so I would probably pause the video. Make sure you write this down on the back side of your worksheet paper or on a piece of notebook paper or something. All right, so we have g of x is equal to 1 plus the cos of x. All right, so I'm going to rewrite that. That is not the standard format of writing these. So if you were to rewrite it, you would have that the cos of x plus 1. That's how we're normally used to writing it. Now, if you think back to parabolas and stuff, what would the 1 do to your graph? So the 1 would shift the graph up 1. Okay, so if all of this thing is doing is just shifting the graph up 1, would this be periodic? So I would say yes. So yes, g of x has to be periodic since cosine of x is periodic. Okay, so then it asks, what's the next question? How is the period of g of x related to the period of f of x, where f of x is just cosine of x? Okay, so you're basically just comparing the two graphs. So the periods are going to be the same because you didn't, make the graph, the wavelengths any faster or stretch them out and make them longer. So the periods should be the same. The graph just shifts up 1. Okay, so your formula for that would be t equals 2 pi over w, and w would equal 1. So your period, which would be your t, would be just plain old 2 pi. If you wanted to derive it and prove it, that is how you would do that, okay? Because if you look right here, there's no number there, so that has to be the 1, okay? So the amplitude of f of x would be 1, and if you look at the amplitude on this one, it's 1, so they're both the same. And that's because there's no number right here in the front. And of cos of x, there's no number in the front. So that would change your amplitude. So they are both the same. So your graph should be something similar to this, your short answer question. They could change the equation. They could change from cosine to sine or to tangent. You know, they're going to keep it pretty much basic because you don't really get a graphing calculator. They just want to make sure that you understand how the shifts and everything works with everything. With the graph shifting up, does that change the period? Does it change the amplitude? No, you have to add in extra things to make it do that. All right, so I hope that this helps you. Good luck on your test number 2, and stay tuned for test number 3 coming later.